Hey guys, welcome back. Mr. Will here for a video lesson for the group Every Day I'm Calculating for Thursday, May 21st, 2020. So we're back at it. We are exploring properties of transformations. Now, properties of transformation really just means how shapes move from one point to the other. Can you remember the three different movements that we talked about yesterday? Well, really Tuesday? Yes, that's right. We would have translation, reflection, and rotation. Again, that's translation, reflection, and rotation. So looking at this, I have two shapes here. And the question is the transformation a translation, reflection, or rotation? Explain your reasoning. So look at these two shapes. What do you think? Well, what we could do is we could draw a line right down the middle of them. If I were to draw a line right down the middle of them, look at how it moves from this side to this side. And it looks like it kind of flips, right? So that would be called a reflection, okay? So how did this shape move? It would be considered a reflection. If you flip the original figure over this vertical line, and that was you didn't see that, but I drew it. You would get a second figure. So when you have a flip like that, it's called a reflection. If you think about if you would look into a puddle or you look in a mirror, what would the shape look like back at you? Reflection. All right, now let's think about this. How would you describe the lengths of the sides between the figures? So what that means is like this side here compared to this side here. Well, if you count up the boxes, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, you would say that the lengths of the sides of these shapes would be equal. And what you could do is you can look at the lengths all the way around this shape, and you can compare them, and you could say that the lengths of the sides are equal. And the way that you could prove that is by counting the squares of the boxes. How about the angles between the original figure and then the reflection? Well, if I look at the angles, and again, that's where I find my corners, it looks to me like I could describe every angle in my original shape as what type of angle? Well, every one of these angles looks like a right angle. It makes a 90-degree perfect square. So every angle would be considered a right angle. How about this shape, the reflected shape? Well, that also has the exact same angles. They would be considered right angles. Are any of the sides of the original figure parallel? Well, sure. If we look at the sides, I kind of scribbled all over it. But if we looked at the sides, we could see that this line or side is parallel to this line, which is parallel to this line. So we would have multiple parallel lines. And then if we change our colors, it looks to me like this line here and this line here and this line here are all also parallel. So it looks like we have two sets of parallel lines. So if these lines are parallel on the original shape, the shape on our reflected shape, the one that we flipped over, also has the same number of parallel lines. So today what we're going to be doing is we're going to continue to explore properties of transformations. And again, that's just how shapes move from one point to another. So work hard, ask questions, and I will see you back here on Tuesday. Don't forget, at the end of the day on Friday, IXL lessons are due and problem of the week are due. Have a wonderful weekend. I'll see you on Tuesday. Thanks.